Hello everyone, my name is David Talby and I'm here today to talk to you about the identification of DICOM files in AWS HealthImaging. Johnson Labs' role in the ecosystem is to provide state-of-the-art healthcare-specific language models. We are the primary provider of medical LLM models and NLP models to academic medical centers, pharmaceuticals, and health IT companies. And one of the things people do with our models is de-identify data. You need to anonymize data so that you can share it for research purposes, do a lot of the secondary uses, be able to build predictive models on different things, and just in general make better use of the data. When you de-identify, you either do it at a very high accuracy to the point where really it's regulatory grade and you can certify it's de-identified, or it's not good enough. It does not help if you de-identify at 80% or 90% accuracy. It needs to be done right the first time. Another thing we really need, especially when we work with solutions like health imaging, is we need something that would work at scale. We need to be able to de-identify 100 million, 300 million, a billion images, and to do this in a fast and cost-effective way. When we look at DICOM images, there are a few challenges. First of all, historically, there's going to be PHI that is kind of burned into the pixels. So as you can see, you need to visually understand the image, find the text, and only redact the fields where there is PHI. You cannot redact everything because some things are laterality are very important to keep. If you're looking at pathology, sometimes you have handwriting on the images, which you need to identify, you need to be able to remove. And beyond the image itself, there's also a lot of metadata that comes with the file. And right now, there are really thousands of different metadata fields for the hundreds of different radiology modalities that are there that we need to be able to find, identify, and select from. Here we are happy to introduce our turnkey solution that integrates with AWS HealthImaging, so that if you use it as your kind of cloud-based PAC solution, you're now also able, really with almost zero work, to also create basically the research shareable data sets of all of your images. There's a whole full solution architecture. There's a Python notebook that will show the whole solution runs within your environment. Your data is not shared, does not ever go anywhere, so you stay within security perimeter. And what we're able to do is take the images, run through any identification that you want to configure, and create basically a new image set that you can immediately use. With that, I want to hand off to Hasham, my partner in crime, who will show some of the code running. Thank you.
Hi everyone, I'm Hasham from Johnson Labs, and now we'll be going over the implementation part. How do we actually make that happen in AWS HealthImaging? So there are 3 steps. First, we pull data from S3, then we process it in SageMaker, and then we push the data back, the de-identified results, back to S3. So the first step is actually to pull data from AWS HealthImaging. We do that by using AWS libraries, and the first thing, as you can see in the code, is we just go over and pull the data and store it locally. All of this is happening inside SageMaker, so nothing actually leaves AWS environment. The code and everything is running locally inside SageMaker. So now that we have got the data pulled in, we start the library, and then we actually run the code to de-identify and store the results. So let's go over that first. So we start the session, we set up the library, licensing and everything, and it's just a few lines of code, but what it does underneath is that it loads the files from the local store, processes it, and as you can see, this is what the files look like. So this is a DICOM file. This is the metadata of that file, and we de-identify both the metadata as well as the image file of the DICOM, and then we store it locally first to keep a copy of it, and then we essentially just push it to S3 again in AWS HealthImaging AHI. That's essentially it. It's only 3 steps, and it all runs in SageMaker. Thanks for watching.